Alright, this is Mr. Gillum, and today we're going to apply some theorems about angles. We're going to learn about angles today and some of the different things that angles are and some of their theorems. And adjacent angles are the first thing we're going to talk about. You probably are familiar with adjacent angles or heard the word adjacent, but basically we're going to run through a little vocab review so we're all on the same page. The definition of an adjacent angle is two angles that lie in the same plane and have a common vertex and a common side but no common interior points. So what they mean basically in fancy words is they're just saying the angles are side by side. Okay, angle 1 and angle 2 are adjacent. So see how angle 1 and angle 2 share a side and they both come to a point at point B. Therefore they are adjacent. Angle B, CBA or angle 1, they're touching, so they're adjacent. And they have the same little endpoint right there. They share a vertex is what that's called. Okay, a linear pair. Now we ran across this word when we were doing some truth table stuff, and we were doing conditionals maybe, or if-then statements by condition. I'm not sure which one it was, but we had to look up what a linear pair was. A linear pair is adjacent angles, no common sides that are opposite rays. That sounds really, really tricky, but basically it's a linear pair or two angles that end up like together they make a straight line. You see how together they make a straight line right there? So angle 1 and angle 2 would be a linear pair. It's a pair of angles that their rays make a line. That's basically what it is. So honestly, we could also say that angle 1 and angle 2 must be supplementary, or they must add up to 180. And now I'm not sure how familiar you are with the word supplementary, so we're going to talk about that today too. But first let's talk about vertical angles. Okay, vertical angles, they're my favorite and they're the easiest one to remember, I feel like. Vertical angles basically are just angles that are right straight across from each other. So angle 2 and angle 4, you see how they're exactly right across from each other? Angle 2 and angle 4, those are called vertical angles. And something about vertical angles is that they're the exact same degree measure. They're the exact same degree measure. Vertical angles. Right there and right there. They're congruent measures. Angle 1 and angle 3 are the exact same degrees. Angle 2 and angle 4 are the exact same degrees. So they're the same exact degree and lengths. Oh, better do two of them there. Okay. So vertical angles is what those are called. It says name two adjacent angles whose sum is less than 90 degrees. So what I'm going to do first, I'm going to label my diagram. I'm going to just call him A, B, C, D, E, F, G, H. Okay, and we'll call this guy right in the middle, we'll call him O, just so we have a reference for our angles. First it asks us name two acute vertical angles. So first things first, all of the angles look acute. As far as if I look just G, O, F, if you're just going from one to the next, they're all going to be acute. However, I could also do like G, O, B. That would not be an acute angle. An acute angle is just an angle that's less than 90 degrees. So two acute vertical angles. Well, if I'm looking at an acute angle like this one right here, this is my acute angle, angle BOC. If I'm looking at that, it is an acute angle. It's less than 90 degrees just by the eyeball test. Its vertical angle would be right here, and it's also equal to it. Angle BOC and angle GOF. Those are vertical angles that are also acute. Okay. It could ask us two obtuse angles that were also, or two obtuse vertical angles. Then if we want to do that, and it doesn't say this, but for example, if I did like GOB, then its vertical angle would be right here. And then these angles would be exactly equal, and these angles will be exactly equal. Okay, so vertical angles, they're exactly the same degree measure. They're congruent degree measures. And so I think we've answered that question thoroughly. Theorems, since I've been talking about it all day long, let's just go ahead and put it in words. Vertical angles are congruent. Okay, so these are the specific degree measures here, so you can see them. 127 right here, 127 right here, 53, 53. They're exactly the same degrees if you're looking vertically, straight across from them. They're called vertical angles. The angles in a linear pair are supplementary, and we kind of talked about that already too. So the linear pairs here would be line MPL and JPL would be a linear pair because it makes a straight line right there. Or we could do MPK and KPJ. I mean, there's a bunch of them. Okay, there's a bunch of linear pairs. As long as the two angles are right side by side and they make a perfect straight line, then they're a linear pair. Okay, also meaning that in a line there's 180 degrees. So if you didn't know that before, now you know there's 180 degrees in a line. I could add my 53 with my 127 and it would equal 180. Complementary angles. They complement one another. That just means that they add up to 90 degrees. They don't have to be right next to each other though. They could be anywhere and still be complementary. 25 degrees and 65 degrees. Looky there. They add up to 90 degrees. Therefore, this angle is complementary with this angle. Or they could be apart. 50 and 40. Those are complementary angles because 50 plus 40 equals 90. So complementary angles, their sum is 90 degrees. They add to 90 degrees. Supplementary, kind of like complementary, easy to get them confused. Supplementary, they add up to 180 degrees. So a linear pair would be an example, like this one on the right. With the 130 and the 50 degrees, makes a perfect line. They're a linear pair because they're also right next to each other. However, they might not always be next to each other. You could still say that 110 degrees and 70 degrees are a linear pair because they do add up to 180 degrees. So that's an important part to remember about supplementary. Now let's throw a little algebra in the geometry mix here. Okay, it says this question asks us to find the measure of two supplementary angles if the measure of one angle is 6 less than 5 times the other angle. So it's like a long question it seems like, but what I noticed right away is I'm finding the measure of supplementary angles. All right, so that means I have two angles and they have to add up to 180 degrees. First angle plus the second angle has to equal 180 degrees. And that's going to be really the key step here is setting up our equation. I think we're pretty familiar with some of the key words in these, but supplementary itself means the angles together will add up to 180 degrees. If the measure of one angle, so the measure, let's just call one angle x, we don't know what it is. But the other one, it says if the measure of one angle is 6 less than the first, 5 times the other angle, oh, well, okay, let's see here. 5 times but 6 less that, then we should be able to solve our equation. Okay. I don't know either of the angles, so I call the first angle x. The angle that it's describing is 5x minus 6. 6 less than 5 times the other angle. All right, so now I have this algebraic equation, and I know that I have like terms here. X and 5x make 6x minus 6. So 180. And we'll just go ahead and continue to solve algebraically. And we could just throw the properties on here too if you really wanted to, but I'm not going to make you do that today. I just want you to use algebra to find these answers. So we'll do it the old-fashioned way. 186 divided by 6. I know it's probably been a while since you've done that. Minus 18, so with that, it's always good to review. 31 minus 6, remainder 0. So therefore, x must equal 31. All right, so supplementary keyword must add up to 180. They could ask us something about supplementary angles again, I guess. Never mind. I thought they were going to say complementary, but no, supplementary again looks like. It says find the measure of two supplementary angles. If the measure of one angle is 6, oh, we just did that problem. No wonder. Perpendicular lines. Let's talk about perpendicular lines. It says, did we do that one? Holy mackerel. Yes, we did. Did I put the same one on there twice? Oops. That's all right. If it said complementary, this guy right here will be 90. The two angles adds up to 90. If it said complementary, must have forgot something there. Okay, perpendicular lines. Lines that intersect to form 4 90-degree angles. I'm sure you've done perpendicular before. At the intersection of the two particular lines, there are 4 right angles and 4 congruent adjacent angles. So all these words that we're just learning, they're congruent, they're adjacent. There's 4 right angles, there's 4 congruent adjacent angles. All these things are perpendicular. So I think that should be probably review for most everybody what a perpendicular line is. But now we're going to apply that algebraically. So find x and y so that KO and HM line KO and line HM are perpendicular. So we need to make sure that line KO, this guy right here, and line HM are 90 degrees. So I know I have a 90-degree angle here, a 90-degree angle here, leaving 90 for each of the final two because they are vertical angles. So what I'm seeing here is this guy right here is vertical with this guy right here. They're vertical. Maybe I did a different color, you'd be able to see better. This guy right here is vertical with this guy. Okay. Therefore, through the definition of vertical angles, and we're going to throw some proofs in at you here in another day, I know that the sum of these happens to be complementary, happens to equal 90 degrees. So 3x plus 6 plus 9x must equal 90. And I know that I could also say 3x plus 6 plus 9x is also equal to the vertical angle, 3y minus 6, or plus 6. Okay, so what I'm going to do first is, since I have two different variables that I'm working with, is I'm going to actually solve for one of my variables. And unfortunately, this second equation, I don't want to really do that. I better do that because I have two variables. But in my first equation, if I go ahead and solve for x initially, I'll have a value to plug in right here. So first I'm going to do some simplifying. I see 3x and 9x makes 12x plus 6 equals 90. And I'm just going to solve this little guy right here. 84, 12x equals 84. Divide by 12, divide by 12, x equals 7. All right, so now that I know that x is 7, that doesn't answer any of my questions. Okay, it answers this one, half my question. So now that I know x is 7, you know, before I start substituting anything here, I'm going to go ahead and put these together again. 12x plus 6 must also equal 3y plus 6. I'm going to plug my 7 in. 12 times 7 plus 6 has to equal 3y plus 6. And I'm going to do my little simplifying, combining like terms, and finally solving. And if you don't remember, I'll tell you a little trick. Let's see here, what would that be? 5, 26, 27, 28 equals y. And the symmetric property says really we want it to be y equals 28. So if y equals 28 and x equals 7, we have found x and y so that they are perpendicular. We knew this had to be 90 right there, and we knew the sum of those had to be 90, and we also knew 3y plus 6 equals 90. Now, we could have done it the other way. We could have said, well, 3y plus 6 equals 90. We can go ahead and sign y first and then plug it in for x. That would have been fine too. There's different approaches. You could do whichever way you prefer, as long as you know that vertical angles are congruent. And we got one more here. And this one's not so bad. It says, find x so that AD is perpendicular to CE. So here's AD. Here's CE, and it's telling me that these are 4 right angles right here. And if that is the case, then I know that 4x and 5x together must equal 90. Oh, this is just a baby problem. You guys can all do this one. X must equal 10. And it doesn't say find the measure of each angle. It just says find what x is. But if we wanted to find it, that would mean this is 40 degrees and this is 50 degrees. Could solve it from there. Just plugging that x in there. Okay, that's it for today. Hopefully you are more familiar with supplementary, complementary, vertical angles, perpendicular lines, and you can apply that information geometrically.